Welcome everybody to IaaS, PaaS equals heart. In this session we're going to do a crossover on IaaS, PaaS, and your on-prem devices so you can get a sense for new ways to use the cloud beyond just standing up a web role or some sort of VM inside of Azure. So to get started, my name is Brian Blanchard. Put a couple of my contact information bits up there if you want to get a hold of me after the session. I'm an IT leader by appointment. Been stuck in roles like CIO, chief architect, a number of other titles in a few different industries. But ultimately, I'm a geek by choice. So I've been a hands-on developer, worked in BI, worked as a app dev guy, all kinds of different positions. And I highlighted startup there because that's been a real defining point in my roles, having to jump between development one day, BI another, and infrastructure another in a number of different positions. So it's given me a unique perspective on Azure because I can see the app dev and the infrastructure side in more of a holistic picture. Because of that, I've been in Azure in the cloud since before Microsoft was, and started before CTP was released in the Amazon stack. Took a lot of startups into Amazon and the cloud services, and then when Azure rolled around, started moving our more Microsoft-focused startups into the Azure realm. Since then, I've released more than 150 apps into the cloud as a whole, and delivered more than 100 of Microsoft's Azure boot camps, helping developers understand what the cloud is and how they can utilize it. And because of that, Microsoft has put me in a role of an Azure VTSP, which means I work both for Oakwood, my employer, and for Microsoft to help them out with educating end users and businesses on how to utilize the cloud. So in our session today, we're going to focus on a couple of customer architectures. And this is all about feeling the love of the cloud. The first one that we're going to cover is a pure PaaS play. I've titled that How to Save Your Butt When You're Out of Ammo. And trust me, the title's relevant. We'll get to that in a minute. The next one is the PaaS IaaS crossover, and that's controlled and anticipated explosions. And the first is a full-blown hybrid, how we go from the 1980s to 2013 in a couple of hours. So we'll talk about these deeper as we go through each of the sessions. But before we get into that, let's cover some basic groundwork. There are a few acronyms in the title of the session, so I'd like to cover what those are and how they make sense. So what we see on the screen is the usual on-prem or hosted stack, everything from networking up to your applications. In a traditional environment, we manage and own all of these different pieces. But the cloud is just an evolution of the ways we manage these. So the first evolution that I think almost everyone here would be focused on is the private cloud. That's about automating and better managing those resources from the virtualization down to the networking so that you can take the most advantage of the resources you have, reallocate them, control them in ways that you can't in a one-to-one ratio between steel and applications. The next evolution is the IaaS evolution. In IaaS, if we can automate those private cloud pieces, we start to look at the concept of take what's automated and move it over to a vendor. Let that vendor take care of the virtualization, the servers, the storage, the networking, all of those type of components. That frees our teams up to focus on the more important things, like making sure the OS is correct, or even higher on the chain, making sure the applications are functioning correctly. The next evolution then moves into the PaaS space. If we're automating those low-level steel-related tasks, can we automate the OS and middleware tasks? And this is your PaaS, or Platform as a Service approach. Here, we don't focus on anything but applications and data, the things that really generate revenue for the business. And then finally, we have software as a service. We're not going to spend much time there today, but a lot of the concepts we talk about can work with that role as well. So the general evolution is IaaS, or infrastructure as a service, PaaS, or platform as a service, and your on-prem devices. When we mix these three together, we get some really powerful solutions. And at the backbone of all those is a tool set called VNet, which we're going to spend a little bit of time on today. So to get there, we talk about cross-premise connectivity if you want to go from IaaS to PaaS to hybrid. It's an absolute requirement, because otherwise these are three segregated data centers that can't talk to one another. So there's two ways we can get there. We have a machine-to-machine network connectivity, or machine-to-site, which is part of the dynamic routing that's now available with Windows Azure Virtual Networking. Or we have the site-to-site networking connectivity, which is better known as VNet, or virtual network. These are two different ways that we can connect up machines in each of these different types of environments. So why would we need these? There's two core reasons. The first, if we want to go cross-prem. So let's say we have a virtual branch DC in the cloud, and we want to connect our data center up with multiple branches. The cloud's one great way to do that because it can serve as the center point to transmit data back and forth from all these different branches and carry data from place to place. It can also give you a way of isolating the cloud, locking it down so the outside world can't see it. And now the only way into your cloud is through your DNS, your DHCP, your DNS and your AD through your domain controllers. So it's your own controlled private cloud that's just not in your infrastructure. So it gives you a way to extend your data center and capitalize on resources that you don't have to purchase. The next is Azure only. If we're building the IaaS and PaaS type of solutions, then we may need a virtual network surrounding the things we have in the cloud, even if they're not touching our on-prem resources. So a couple of reasons why we would do that is to get things like a static IP persistence or some dip-to-dip communication. Just a couple of reasons why we'd use virtual networks, and they'll become a little clearer as we dig deeper in. So the big question to ask yourself when you're looking at IaaS, PaaS, and hybrid is, will you need a virtual network? Because we know we can use PaaS by deploying a website out. I'm sure by now you guys have heard a lot about what you can do with IaaS and deploying VMs out, but when do we need to go further? So there's a couple of key indicators that the topics we're talking about today will be relevant. If you need a persistent IP address because you need to have consistent communication from machines, you're going to need VNet. If you have any conversations around hybrid on-prem cloud apps, you're going to need a VNet. And then finally, if you have multiple cloud services or multiple VMs that you've deployed out to the cloud and you want to connect those up together, you'll need a VNet. So if any of these three cases are relevant in your environment, then this is going to be a relevant conversation for you. So let's first take a quick look at what VNet actually is and where we can see this in the environment. So quick show of hands, how many people here are new to the cloud and have not seen Azure yet? Only a couple. Okay, so what we see here is the basic Azure portal. I've jumped ahead to cloud services, but there's a couple of things we can see here. Just running through our acronyms, the PaaS area consists of your websites or your cloud services. These are that platform as a service. You don't care about the OS, you don't care about the patch version, you just deploy your code out and it runs. So everything below your application is managed by Azure being the third party. Then you have your virtual machines. This is the IaaS area. And this is where you see all those virtual machines you've built out, and it's much like a hypervisor you'd have in your own data center. Connecting these, the part we're talking about today, is in the networks area. So this is VNet. We have two types of virtual networks. The first one is an Azure-only virtual network, and we have one here named Azure-only that fits that bill. And this is basically just wrapping up things in Azure, doesn't touch any other premises or any other cross-connectivity, and stays right inside of this particular service. And when we look at this dashboard here, we can see the resources that are using this virtual network and some basic connectivity data. Digging into the configuration, we can see a little bit more. We can see that inside of this virtual network, we can define some things like a DNS server so that we can control access to the servers, routing to the servers. We can control point-to-site connectivity. That's the ability to connect up one machine with your Azure solution. So say you have a SQL Server deployed on-prem and you want your applications in the cloud to be able to access it. Instead of creating a full site-to-site connection, you can actually have that SQL Server VPN into the cloud and have a connection through a VPN tunnel that would allow Azure to access it directly. So that's your point-to-site. The next is site-to-site connectivity, and this is basically just an a edge-routed firewall connection through your network and your basic connectivity. Man, my mind's going blank today. So the main thing we're defining inside of this VNet is the address spaces that are going to govern all our computers that we deploy out. We set a basic address space here of .0 to .16. We have a starting IP address of 0, ending of 16, and then inside that we set up some subnets that go from .1 to .0 to .1.24. So this is what's going to govern all of our IPs for our servers independently. On the other hand, we have our Azure connected network, and in here we've gone a little bit deeper. We've actually defined DNS to govern the routing to those servers, and we've set up that site-to-site connectivity. And the word that I was stalling on before was VPN. So once we have this in place, we'll have that VPN connection between our on-prem site and the Azure connection so that we can go back and forth without opening up a bunch of ports. Here we've gone a little bit deeper with the virtual network address spaces, and we've actually aligned these with our Office so that whenever we spin up a new server inside of Azure, we know it's not going to conflict with anything that's in a subnet inside our current environment. So these are the basic configurations of VNet. And we'll dig into each of those a little bit deeper in just a minute here. So the important part isn't so much VNet. You can get that by looking at a couple of instructions online and figure out how to set one up. The important parts of what we want to cover today are really the customer architectures. So the first story we want to look at is the one about ammo. We actually have a number of customers that are in distribution, e-commerce, retail type of spaces. Any avid hunters in the group or shooters? Only one or two? So a few months ago, there was an absolute run on ammo. You couldn't find it anywhere. You'd call any outfitter, and they wouldn't have anything for you. Well, one of our customers started to see this immediate bombardment of their website. It was going down frequently from overutilization. Pages were slow. Just a ridiculously painful scenario for them. Now, they were working on a different infrastructure that didn't fit very well with Azure, so we couldn't do much for them. Now, but what could we do in that same scenario? Well, many other cases, we've worked with customers in the retail space or the e-com space where it's very easy to just spin up more instances if you're already in a PaaS play. Or if you're not, you can take pieces of your website, deploy those out to a solution in the cloud, and point them to a SQL Azure database so now that you can take care of some of the load. So a common one we'll do for e-com customers is take their catalog, put that in a database that's out in the cloud. It's data that if it leaks, nobody's hurt by it. And then you can put things like your product page out there. So what was killing this particular customer is users were just sitting on that site looking at a product page for boxes of ammo and hitting refresh over and over again until the thing would actually have inventory there for them to buy. In this case, it'd be great to do a simplistic bursting mechanism. So let's take a look at why and how we do that. So we talked about IaaS, PaaS, and all these other solutions. Why would we want to look at PaaS? There's three core reasons. The first is that PaaS is cheaper. There's a heck of a lot less work for your developers to do because they're just deploying right outside of Visual Studio. There's no need to set up an infrastructure or any of those things, so you can go from the application idea to the actual product a lot quicker. And there's less hindrances to actually getting the product up and running. Second is it's cheaper. If you're not maintaining the operating system, if you're not patching, if you're not configuring things at the OS level, you have less maintenance. You can get the thing deployed out faster and keep it going longer with less cost. And finally, it's lower risk. So the biggest difference between IaaS and PaaS is if we're looking at a PaaS role, it's always a vanilla instance of a VM. You're still running on a VM, but it's 100% consistent from one PaaS instance to another, and that doesn't change. Because of that, we have a lot less lower risk. So let's take a look at some of the PaaS stuff inside of the cloud. Jump back over here. So how many developers do we have in the room today? Oh, good number. That's great to see. I was so afraid that I would lose 100% of the audience at this stage. So our goal today is to kind of create this bridge where people on both the networking side and the development side can get a good feel for what it looks like to work inside of Azure. So we're going to do a quick introduction to just building an Azure project. So we'll go ahead and start a new project. And we're going to go to the cloud section in Visual Studio, make it a cloud service, and we're going to call this the TechEd project, and hit OK. Once that pops up, I'm going to choose an MVC4 web role, just add that to my solution, and I'm going to change its name to Hello TechEd. And for those of you in the audience who are not developers, this is kind of the common interface that our developers see when they start up a new project. I just want you guys to see this because we're going to walk through how we control the infrastructure through this project. So we're just going to make a simple internet application, and we're going to put it in a Razor language for the views. And while this is spinning up, I'll kind of walk you through a little bit of this. For the developers in the room, when we talk about Azure, we're really talking about 3 files. That's all we care about as a developer. We don't care about the servers. We don't care about the mechanisms to manage them. We care about 3 files. Other than those 3 files, our code is exactly the same as it was before Azure existed. So just to show that off here, I'm going to make my existing project the startup project and just run this real quick. And this is going to spin up the sample MVC project that every developer in the room has seen a million times over. Nothing fancy about it, nothing real elaborate. Other than the fact that it's on the wrong screen. So it's going to go ahead and spin up my project here in Azure real quickly. And it's loading up. And it's actually popping this up in IaaS. So here's our basic MVC project. Nothing normal, or nothing outside of the normal, just a usual introductory MVC project. So we're going to go ahead and close that down. And the only thing we need to do to make this an Azure project is in Solution Explorer, we have another project here, a CC proj file, that was auto-created for us called TechEd. We're going to set this as the startup project, and in here are those files we care about. The first is the proj file itself. It has some binary behind the scenes that tell Azure what roles and which programs it actually needs to include when it deploys. And then we have two that we can actually change. There's the CSDEF file, which is some basic configuration settings. The thing that's really important about this is I clicked the wrong one. The CSDEF file defines a lot of things about this application. On the top here, we can see that we have this site named site that the cursor's on currently. Inside of it, some binding, and it points to an endpoint called endpoint 1. That endpoint 1 is actually opening up port 80 to this actual application. So from here, with 2 lines of code, we can actually poke a hole in the firewall to this application. So it's a very important thing for the networking guys to understand. The next is we have another area up here where we define a VM size. And we're saying that this is a VM size of small. That has some controls about how much processor and how much memory it has. There's various different sizes that we can choose from here. But ultimately what's happening is in this line of code, the developer is choosing the size of the VM. So we need to be aware of this as well. Because in each one of these areas, we need our infrastructure friends to help us determine if these are really wise choices or if we're doing something that compromises security. So there's a couple of other things there, but those are the ones that are really worth pointing out today. Then the next thing we have is the CSCFG file. In here, we have another setting that's an infrastructure-specific one, and that demonstrates how many instances of that VM we have. Now, this one can change once we deploy the code, but that CSDEF file is compiled and deployed with the code. So from here, we can always say we want to have more instances or less and kind of scale that up and scale it down. But when we deploy, we're stuck with that particular VM size. So both sides of the fence have to be aware of this conversation. And it's going to get even deeper as we look at some more advanced scenarios. So I've switched this over to be the startup project, and I'm going to go ahead and hit run, and we're going to see something different happen. We now see this compute emulator pop up. It was just for a second there, but what it actually did is it's standing up an instance of VMs that look identical to what they would look like inside of Azure. We can see our code's still the same, so we have our legacy application, no significant changes here. It all works the same as before. All we've added are those 3 files. So let's dig a little bit deeper. This is a pure PaaS front end, but to demonstrate our power of the IaaS PaaS crossovers, we're going to look at SQL Server as an example of our back-end workload. So in a pure PaaS play, we can go ahead and set up a connection here. And since we're in MVC, I'm going to go into our models, and I'm going to tell it to add a new entity data model. And once this pops up here, I'm going to call that webinar. And I'm going to generate it from a database and set a new connection. And off to the side here, I have my connection settings. Let's make sure they didn't carry over. Okay, it did not. And I'm just not showing you this part because I don't want you to see my passwords. So on my screen here, I'm going to set a server name, or I'm not. There we go. So I'm going to plug in my server name. And the server name's a really nice one. It was generated by SQL Azure. So it's a very long URL that points to a server on SQL Azure. And I'm going to say I want some SQL authentication associated with this. And plug in my username. And I'm going to plug in my password here. Let's save that. And then I'll choose a database inside of it. So all of this to this point is very similar to what you would see if you were setting up any other connection to a SQL server. The only difference is we pointed out that this is a server name that's hosted on SQL Azure. So we're making an assumption that we've already taken our legacy database and deployed it out, or we're using some new feature set that we've deployed out to SQL Azure. And I'm going to go ahead and just stand this up. And I promise there is relevance to this for the non-developers in the room in just a moment here. But I'm going to go ahead and stand this connection up, let the database objects go ahead and get generated, and we're adding those models in. And of course, as the developers in the room can tell, I'm only using MVC4 and current versions of Entity Frameworks and none of the cool stuff that you've already seen this week. But pretty much the same concept, even if you download the latest bytes of Visual Studio. Next thing I'm going to do is add a quick controller here, and I'm going to call it Contoso, just because I'm using some Contoso data in this contact table. And we're just going to make that a standard MVC controller, and I'm going to choose my, oh, not yet, I'm not. Sorry, one thing with Entity Framework is you do need to build before you can actually use some of the cool Entity Framework stuff. Now I'm going to add my controller. And we'll call it Contoso, MVC controller. And I'm going to choose my model class to have the contact object that we see in the database we just grabbed. And choose my webinar entities. And go ahead and add this in. And this is going to create the web pages we need to actually see some data in here. And again, this is just setup. We're going to use this setup a couple of times to demonstrate the infrastructure connectivity as well. So that's up and running. We'll go ahead and run our project here real quick. And it's going to be the same as our project was before, but now we're going to have a new section to this project. It's a page called Contoso that matches that controller we created. So we haven't done anything fancy here. In just a couple of minutes, we've connected to SQL Azure. We're pulling some data back. We're throwing it up on a page. Looks amazing, right? Yeah, not really. Nothing fancy. For the developers in the room, we do this crap every single day. For the non-developers, it's about to get really neat. What we've done here is we're using all a pure PaaS tool set. This is the fastest, easiest, most capable way to go. But there's a couple of problems with this. Anybody in here bound by HIPAA or other external compliance bodies? Okay, this solution we just did is a violation of HIPAA. It is not a compliant solution. It's great for a simplistic shopping cart or something super simple like that. But when you start to think about some of the security and compliance ramifications, it may not be the best, especially if we're talking about really strong proprietary data. How many people here have ever used stored procedures or jobs for anything really elaborate on the back end? Okay, that solution may not fit here either. So you can run stored procedures in SQL Azure, but you don't have a job agent today. So what if you need to do some background work on this data? Well, it's not really there. You'd have to create a worker role and some other programmatic stuff to manage that. But there's easier ways to get there. So our next thought is let's use SQL Server. We can take an instance of SQL Server, deploy it out to a VM that's on our own dedicated VM that nobody's using. There's not as many security risks. And we can get our data out of SQL Azure. And we can apply our jobs or do anything else we want to it. So let's just take a look at some of the pieces behind that on our slide deck here. And these things we have up on the screen are more for the people at home or for anyone who wants to download the slide afterwards. I'm highlighting the code on those slides so that you can go back and see what we actually changed from each step. So when we talk about PaaS and IaaS side by side, this is how we would actually connect our cloud apps. So we instantiate a SQL Server instance on a VM. We deploy our data out to it. We want to connect it up. At first, everything's connected by VIPs, or virtual IP addresses. There is some direct connectivity using virtual networking, but let's say we don't put that in at first. So we have our cloud service. It's this little blue cloud up in the top here. It's a really cool cloud service. It's that website we just built. It does some great things. Next to it, we have this other SQL Server. That SQL Server is then sitting inside of the cloud, and we can access it with normal data. It's got a couple of strengths. It's a really simplistic, straightforward, easy solution. You have tenant autonomy throughout each of the stages of the cloud. And you have the VIP swap, which is a really cool tool set for developers because it lets them click a button to actually swap out a staging and production area for rapid deployment. So basically deploy your website in 3 seconds. And this is a very easy solution for local dev and test scenarios. But it's got some weaknesses. The biggest one is there's some higher latency because it has to go outside through the cloud to get to the data. The second is that we're actually poking a hole here. So for us to go from that PaaS solution in the upper cloud to that SQL Server solution in the lower cloud, we have to leave Azure, go through a load balancer, come to another load balancer, so we're on the front plane of the website, not the back plane. Then we go through that load balancer to SQL Server through port 1433. Anyone here see any problems with that? Not too many people. So opening up 1433 is the biggest security risk involved with SQL Server. As soon as you open it up, anyone in the world who can ping that port knows you have a SQL server with data on the other side, and they will begin relentlessly beating that server. So doing that in a public cloud format where everyone knows that there's tons of servers here, and they can do some port scanning to find who has 1433 open, you've put yourself in a very dangerous situation. If you move to SQL from SQL Azure, not because of a compliance reason, but because the data was a little more complex, you may be okay here. But if you're really focused on compliance and data security, this is a less secure solution. Yes, sir? Mm-hmm. You can. There's actually a slightly easier way to do it, though, with VNet. So if you needed to go this approach and you want 1433 exposed, you can use ACLs and control that access in and out, but not necessarily the easiest dev solution. Yes, sir? You can use non-standard ports. And actually, the first time I gave this presentation was for a webinar the day after they launched IaaS. And it's undocumented at this point, but if you try to call 1433 from the outside world, there's packet blocking that catches the SQL command and won't let it through, but lets everything else through. So you actually have to change it to a non-standard port. Most people are changing it to 1533 out of the chute. But either way, you still have a port exposed to get directly to SQL Server, so you can add security through obscurity, but probably not the best idea if we're talking about highly confidential data. So these are a couple of challenges that we have with this scenario. Now, I'm going to demonstrate really quickly how easy it is to put this scenario in place with just a line or two of code changes. So going back to our solution, let me actually close this out here. Going back to our solution, I'm going to go to Solution Explorer, and I'm not going to change the web page or anything else. I'm just going to delete this model here. This model is basically what allowed us to connect to SQL Azure before. So it did all the heavy lifting. And once I delete that model, I'm going to go ahead and add a new model, and I'm going to give it the same name just so I don't have to do too many code changes. And in this model, we're going to name it Webinar again. And we're going to generate from a database again. Still nothing significant changed. We're going to set up a new connection here. And this time, I'm going to go to a VM that I created that's in a cloud service called side-by-side-SQL.cloudapp.net. And note I put comma 1533 up there because I'm using security through obscurity here to keep people off of 1433. So could be a good scenario. Let's get my username and password here real quick. Save that password off. And in this database, I've already migrated my data over, and I've got that webinar table as well here. I have a couple more tables. If you noticed before in the SQL Azure model, I didn't have things like master or MSDB. You just don't have those with SQL Azure because you're not as worried about that in a PaaS world. But since this is a VM running SQL Server, it's a full SQL Server. Everything's just the way you'd expect it normally. So I'm going to go ahead and actually set up this model here. And my entity data model wizard's asking what data I want. And just like before, I'm going to say that I want all the data down to the contacts. And I'll go ahead and finish. And it's going to create very similar files to what we did before. The biggest change here is that I've changed that connection string. So now, let me go ahead and rebuild and run my program. I'll see a lot of the same data. Oh, I did get a build error. And that's actually because when I changed the names, the wizard probably changed that to a 1. That looks about right. So go ahead and run again, and we're going to get the same startup page just like before. But now if we go to that Contoso page to actually see the data, I'm going to see slightly different data. I changed the data a little bit just so we could see the difference. Before we had a bunch of contacts. Now if you notice in the company column, I've changed all these to the IaaS to PaaS company, so that we can actually see that this is just a new data source. Nothing much changed here. We just moved the data around. So now we're using a VM with SQL. The developers had very little impact because all they had to do was change a model. But on the back end, our friends in the infrastructure team had to build a VM. They had to figure out what cloud services they want. They had to figure out how to allow ports to be open and what ports to open up for us to be able to connect to it. Someone from the data side had to migrate our data. A lot of stuff went on the back end, and we just changed a line of code. So really simplistic from a development perspective, but we now have more conversation. Before, we didn't have to say anything. We stood up the PaaS SQL Azure server. We didn't need our infrastructure friends. We maybe didn't even need our DBA friends because we put the data in there ourselves. The developer's in 100% control of the application. Here, we have a lot more interdependence, so we need to have even more conversations up front. So let's jump back to our deck here. So it covered a couple of the things here. So we still have a little bit more control, an easier dev environment. I was able to run it locally, some things that you're going to see change in here in a few minutes. But we do have that big security problem. We've also added, again, the management and deployment overhead because other people have to get involved to get the data out there. So what's another option we can look at? It's IaaS and PaaS with VNet. So this helps us get rid of some of that security concern. The way it works in this model is we have one load balancer that we're coming in through. We're still hitting our web role in Windows Azure just like we just did. No difference there. The difference is the connection between that web role and the database is completely different. Note we're not going back out through load balancers. We're going direct to those servers. So I've set up the same scenario, and we'll look at that in just a second. But our strengths here is that this is more secure. There's lower latency because they're connecting over a bigger backplane. They're not going through the load balancers. We still have our cloud service autonomy between the two different areas. We still have our VIP swap. We have a little bit more advanced connectivity requirements, which is a little bit of a pro and a con. But our weakness here is we now have to understand VNet, which, as we saw, has a lot of data to it that for the developers in the room is probably pretty foreign. And one of our biggest weaknesses here is that we don't have a full DNS that we can use to get direct to that machine. We're using public VIPs still for most cases to get to the data. We can get around that, but it's a little bit more complex. So when we go this route, we first have to set up our VNet. Jump back to my box. We first have to set up our VNet. Again, going back to the virtual networks, we have our Azure-only one. We've not set up a DNS server. We could if we wanted, but we haven't yet. We're not using any of the point-to-site VPN connectivity. We're not using any of the site-to-site VPN connectivity, but we've set this address space here. This address space is crucial for being able to communicate from the PaaS to the IaaS servers. So to start with, before we even deploy code, we have to identify all of these network parameters that most developers are just going to have go right over their head. Next thing is we have to start by creating our cloud service. In the past models, I could create everything I need right from Visual Studio and just hit deploy and it goes. In this model, since we're adding VNet, we actually have to go in and create a cloud service by going to the compute section, adding a cloud service, and do a custom create. And the biggest thing we're going to change here is when we create this cloud service, we're going to say that it's in this Azure-only affinity group. That's what binds it to that virtual network. And we can give it a name of whatever we want here. Not actually going to deploy to this one, so it doesn't really matter too much. At this point, I could deploy a cloud service package. But either way, go ahead and click accept, and it'll start spinning up this cloud service. And from this point forward, anything I deploy to that cloud service will be inside of that virtual network. So let's say we have another SQL server that we've deployed to that's inside of that network. I've done a little bit more advanced routing on this particular one, so I can call it by name here. So I'm going to go back to our code base. And if we were to do the same thing we did before and create an entirely new solution, there's a shortcut here. I'm going to jump to the web.config. So inside our web.config, we have all those connections that we use to get to that controller from before. Jump to the wrong web.config. There we go. So inside our web.config, we have that connection string to our entity framework data that we used before. So I'm going to scroll down to our data connections, and here's that webinar entities one that we created. If I go on over here, I can do the same thing that we did as when I blew one out and created a new one, and just go in and change the data source on this. So coming over to the data source, I'm going to replace this with the same SQL server that I have inside my VNet, called IaaS VNet SQL. Now, if I were to go ahead and run this, we would see something really interesting. It's going to run, it's going to build, it's all going to go out to the web page, and we'll be able to actually call up that page. But if we go to that same Contoso page as before, we're going to get an error. Anyone want to guess why this is going to error out in just a second here? No guesses? Yeah, you can't connect to SQL. And rather than waiting for this thing to error out, I'm just going to go ahead and kill this here. Can't connect to SQL because it's behind a VNet. We don't have any holes poked there. We don't have any ports open. And there's our nice little exception saying that it failed to open. So we're going to get out of the code base here. and take a quick look at where that's at. So if we're in our virtual machines, before I had that IaaS PaaS one where they're sitting side by side. If I look at that server and look at its endpoints, I can see that I had 1533 open and forwarded to 1433. That's how I connected to it before. In this new one, where I'm looking at IaaS through a VNet, I don't have that port. Actually, I might have that port for testing here. So I'm going to go ahead and delete that. I don't really need that port, though, because that port's not doing anything. So instead, I actually had to deploy to test this one. So this is one of our greatest weaknesses with using this approach, is now we can't get to that server directly, so we can't test it out. So I've got an instance of the standard testing site that I put out there that has a connection through that VNet. And we could also deploy a code that we just changed, and once it gets deployed and out there, it's going to function. But since I'm not inside of my network right now, and since I'm not inside of the cloud, I just can't get to it. So when this goes ahead and runs through, we'll see that we actually have that code. And it looks like it's running a little bit slow right now. That's probably my box. So this connection is going to go ahead and run through. And while we're waiting for that, we'll jump back to our slide here. We'll see it pop up in just a second. So basically, what we're demonstrating here is that we now can't get to that SQL server from the outside world. Once the page loads up, we'll see that we could get to it, and it's just slightly different data. So what we did to get to that, we actually had to make a few other changes. And that's the other reason why I have these slides, so I can show you what we had to change. So I created that project that we just deployed out that's loading up on the web page in another project here. And I'll go ahead and load that up and show you some of the changes we had to make to get there. And this is where it, again, becomes very relevant to have your network friends involved. So if we look at this project, again, we said that we have these CSDEF files and CSCFG files that kind of drive everything in the cloud. Well, for this particular project that I have loading, I had to add a configuration to the code to actually make it join that VNet. So inside of my code in that CSCFG file, I've said here that I have a network configuration. I've said that it's going to join the virtual network side of Azure only. That's what tells it to join into that VNet once I deploy it, and tells the actual VM that my code's running on to join that particular virtual network. I've also given it an instance name here with a role name that matches my project. And I've told it what subnet to join. So this is telling it which DHCP range it needs to join into. So this gives us all of our network configuration, and this is really the secret sauce that lets us connect over to that particular server. I think that's everything there. So moving on, let's say your data is even more secure. This other architecture we have is, we've called it 80 to 13 and 3600 seconds. So in this particular model, we have a customer that has a really old legacy data format that's stuck on-prem. This data is super private. They don't want that data going out to the cloud ever. But they have a scenario very similar to our friends with the ammo problem where they need to be able to burst. Well, how do we do that? Well, we can use the other version of VNet to go from PaaS to IaaS to on-prem and create a comprehensive solution that lets you bridge all three of those using the same VNet tool set. If we do this, we have another cool set of tools. We can capitalize on our existing investments because we bought SQL servers. And how many people in the room here own a SQL server in your company? Pretty much everybody. So you don't have to throw that investment away. You can actually recapitalize on that, keep using that SQL server internally, but use it for those things that are super private, those things that you never want to get out to the outside world. We can still control things a little better now that we're using a more advanced VNet. If we use a VNet with a site-to-site connectivity, we can use that tool set to say that DNS is now going to be governed from our on-prem sources. So now AD that you have on-prem can set the DNS for every single one of your servers in the cloud. You can also tell the cloud to respect your AD for governance of who can access the servers and actually join them into the domain. So under this approach, we've expanded it, and we've made it to where, again, your data center is now expanded out into the cloud, and that's your private data center that you control just like something in your own virtual environment. It's a heck of a lot more secure this way because we're controlling it. We have a lot more granularity over access. We still have the cloud service autonomy because we're keeping our web rollout here in the cloud and accessing our resources here on-prem. And we still have those VIP swap tools. So our developers still have not experienced any significant change, but from a business perspective, we can make the decision of where our data belongs, and we can control and govern it effectively. Our biggest weakness here is that we will have much higher latency. If we make a decision to go with this approach, the biggest challenge is that the data that's out in the cloud has to come in through Microsoft's huge pipe here at the top and come into our little bitty pipe here in our private cloud here at the bottom. So you need to be prepared for some bandwidth increases because they may become necessary if you're going with a VNet cloud to on-prem connection. The other problem is VNet gets a lot more complex. I don't know many developers who can actually implement VNet properly with an on-prem connection, just because it does require a bit of a networking mindset. But let's take a look at a few of these pieces here. So back onto the box. By the way, that one we weren't waiting on, didn't want to wait on before, finally woke up and ran. And again, the big difference here is that it was the VNet company name rather than the other company name. So demonstrating that it actually did function. So looking at our next level of VNet, when we're going from IaaS to PaaS to on-prem, we've created this Oakwood connection. And one thing you'll notice when we look at its dashboard is it's going to show connectivity back to my Oakwood office. So we have our Oakwood virtual network, which is the blue side. Then we have the gateway from Azure that connects up with a VPN connection on a Cisco ASA, I believe 5500 inside of our network. So basic VPN connection from the two edge devices. Then inside of that, we can actually get to the Oakwood office. So I can actually go through these servers and connect to other servers inside of Oakwood right now and start pinging them. It's governed by DNS, so DNS is setting all the IP addresses. We can see the resources that we have allocated, and they all have internal IP addresses that fit with the schema inside of our organization. If we look at the configuration, we can see that these DNS servers are ones that are actually in my office and not in the cloud. And we can see our virtual network IP addresses, so the test subnet, a gateway subnet, and we can also see our connection back to the local network is approved here and go into the Oakwood office. So that's some of the basic connectivity. The things you can't see from here is that there was a lot of other data or a lot of other configuration that we did in the background. For instance, with our ASA, we have a basic setup that I can get to from the dashboard here. Nope, missed it. Sorry, basic setup we can get to from the dashboard, which is the download VPN device script. From here, I can specify what device I have locally. So we used a Cisco. It was a 5500. We used ASA 8.3. There's a couple of other options here, like you can get a Juniper route or a Juniper firewall, or you can use Microsoft and connect through RRAS, which is a really cool new feature set. But either way, you choose what your vendor is, choose the appropriate platform and the operating system that it aligns with. And what this is going to do is spit out a script for us that is now opening somewhere over on my other screen. Or not. Try that one more time. Oh, there it is. So we're going to open up the script so we can take a quick look at what they sent to us. Let's drag this onto the other screen. Got some basic firewall rules here. The most important ones is that we can specify which Azure network IPs come in and which subnet. So people can't just spin up anything in Azure and connect through this. So we can put some governance there. We can also set some things on our end, like the on-prem network range and subnet mask. So this is really important for ensuring that if we're only connecting this because we want to connect to some SQL servers, let's make sure that's all it can connect to, and that the whole company's not going back and forth between the cloud. A bunch of other neat settings, but those are the ones that are really highly relevant. And this is most appropriate in a infrastructure guy's hands, and not really good for a developer to start playing with your edge firewalls. So there's our basic configuration of the VNet. Looking back at our code, I'm going to go to this code base here, which is the one that's deployed. And now I have to make a couple more changes to my CSCFG to make this happen. So now I've specified my DNS servers inside my code. That's got to align with the DNS that we have out in the cloud. What that's going to do is when I spin up this app, again, all of our PaaS solutions are going to a VM. That VM's very vanilla. This simple line of code executes a script whenever that VM comes up that forces it to use this DNS rather than the Azure DNS. So we need to understand that DNS from the infrastructure side to be able to figure out where we're pointing to. Next, I've joined the Oakwood virtual network site, which is, again, the one that has the on-prem VPN connectivity rather than just the Azure one. This is my instance role, so the website or the program that I'm deploying. And I put this in the test subnet. So these things are all defined inside the CSCFG file. So now it's gotten a little bit more complex. Before we were dependent on the network guy to help us out understanding the address spaces, but now we're dependent on the network guy to help us configure the firewall inside the environment. We're also responsible for the network guy to come along and help us write our code so that we know what DNS servers to use and what type of configuration to set up in the code. Fortunately, we only really have to do this once to get it set up properly, but there's still a touch point that we just didn't have before. And then when it gets down to the code, it's pretty much the same thing. In this particular app, I have two connections I'm using. The first is to IaaS on-prem-sql.oakwoodsys.com. That oakwoodsys.com is there because my DNS is governing that now. So I have to use my FQDN from my DNS server to actually get to that server. But that server is actually inside the cloud. So this is still saying on the back plane. It's using my DNS for routing, but I still have to call the FQDN. Then here I have another server. This is an actual instance of SQL running on-prem inside of the Oakwood office that we're going to ping in just a second here. And again, I have to use the FQDN for it as well because it's going through my DNS and it wants to route through that way. So these things haven't changed. They're just like normal connections. But if I go back to our demonstration and go to one that's actually deployed to that VNet, there we go. This is my PaaS on-prem app. I can see a couple of neat things. First thing is I can still get to a VNet app just like I did before. This is going to go to a server that's running inside of a VM in Azure. And I'm also going to pop up my super secret demo. So as this loads up here, what's happening is on this page, we have the same front end. It's using our connection right here to connect to the IaaS on-prem and going extremely slow for some reason. I don't think our bandwidth is very friendly here today. And the next one is using this HQ dev. So it'll be this one over here. And while those are loading up, does anybody have any questions so far? I know we're covering a lot of ground pretty quick. Yes, sir.
Those external IP addresses that you get, can you guarantee to keep those? You can bring the machines down and bring it back up, or does that change the dynamic?
On the Azure environment itself? Yes, that's one of the great things you get with VNet. So if you're not using VNet and you spin up a VM and you have to shut that VM down for some reason and bring it back up, there is a likelihood that you're going to get a new IP address. So you should never use the internal IP on anything that's not governed by VNet. And just to show you that really quickly here, let me pull up our virtual machines. I'm going to go to this one here that is the IaaS PaaS. And if I go to the dashboard, I can see two IP addresses for it. Here's our public virtual IP. Here's our internal IP. If you're not in VNet, you should never rely on that internal IP and instead go through the public virtual IP or the DNS name for the actual cloud service.
But the Rackspace, I get two IP addresses, an internal and an external.
Mm-hmm.
The external, I just use the hosted firewall on the server to get to it. Is there a feature like that in Azure?
There is once you deploy VNet. So when you have VNet in place, you get a consistent, reliable internal IP address. So that's one of the first reasons to utilize it. Yes, sir.
It seems like your project is getting more and more tied to the specifics of this particular infrastructure. How does this correlate with being able to support multi-platform development, develop UAT in production, and repeatable deployments across multi-service database application?
So from which perspective? Being able to change the code or being able to manage the environment? Mm-hmm. That's a great point. The complexity of going from a dev environment to test, to QA, to production doesn't get any easier with Azure. If anything, it's getting slightly more complex. So we're becoming more and more dependent on strong release management. And for those that were here for the keynote, there was an announcement about a new company that Microsoft purchased that's very specifically focused on bringing release management into Visual Studio and give us some workflows that actually make sense for a change. I can't remember the name of the company, and I don't know what it's going to be called when it comes out in Visual Studio, but it's really in line with that type of approach of being able to define different stages of your deployment. And one thing that's already there for us is this CSCFG file. So when we talk about our CSCFG inside the code base, we have right off the bat two versions. A cloud version, which gives us some places where we can set connections, and a local version where we can set others. So you can actually override your web.config and use the CSCFG instead. Then when you're testing locally or in your dev environment, you can go to your test servers. And when you deploy publicly, you can go to the public database server. So those things are already there to some capacity. Yes, sir?
To answer his question, because we have a similar environment where we run slow cheetah software to do the configuration changes for each environment, dev, QA, staging, and production. And based on each configuration, we do Azure deployment projects. So,
Mm-hmm.
like whenever you select that project, automatically it gets deployed through TFS. You use TFS embedded to that.
Mm-hmm.
And you can have a built script on that that will deploy appropriate configuration to the correct platform.
Mm-hmm.
And then you can run it.
Yeah, Azure definitely isn't defined to create your build scripts for you. You have to do a lot of that still on your own and define good, solid build scripts. But there are a lot of tools that can help with it. So let's jump back in. And, yes, sir.
How do you sync between cloud Azure, SQL Azure to on-prem?
So there is a tool set called SQL Azure Data Sync, and it's not necessarily in the scope of this presentation, but we can definitely circle back around to that after we get done going through this data. Cool. So it gave us a few seconds there, and our data went ahead and ran. And what we can see here is it's still, again, the same source code, same website, very similar connection. We're not changing the world here. We're just changing data sources. And as we pointed to this new one, we can see that we're now using the IaaS on-prem company from the IaaS on-prem data structure. So we're just moving from structure to structure again. The real big bang of this demo, though, is this is still in the cloud, still database running on a VM inside of Azure IaaS. What we did that got really fancy here, though, is with those two connections, we added to that IaaS on-prem our special super secret data. This data is only stored on-prem on our local servers. We've now blended that with data that we have in the cloud, and have made it to where we can present those on the same page, in the same model, in the same context. We can use those inside of our code to actually be able to carry that data through. And we had to do a little bit of trickery in the back end to make Entity Framework pull that off, but I see a few developers in the crowd giving a grimace face when they heard that. But basically, we're blending this data together. So what it represents is if we're building a solution, say our e-com, for instance, we can put our catalog inside of Azure. We can set it out there right next to our front end, and it can churn really quickly. There's no risk there. There's nothing confidential. Then when we get to the stage of actually purchasing a product or working with credit card data or something else that we really care about that we don't want to compromise, we can still connect it back to our SQL servers on-prem. Spinning this around, looking at it from a couple of different directions, from maybe the infrastructure perspective. You could use these tools to allow you to set up System Center in such a way that it can monitor your cloud VMs, whether they're PaaS, IaaS, or others, and see it from your on-prem location. SharePoint, you could do similar configurations of a web front end in the cloud and app installation on-prem. So pretty much any workload we look at, we now have the choice to make decisions about each part of that workload to determine where it fits best. And we're no longer limited to just Azure or just any cloud provider. We have the ability to flexibly go from one to another. So, jumping back to our deck here. So just take a quick look again at those changes. Most of what we changed here was network configuration, some basic virtual network, the subnet, and some basic connection strings to connect up to our FQDN to our SQL server. So just a quick demo recap. We looked at VNet, looked at PaaS, looked at IaaS and PaaS together, IaaS, PaaS, and VNet, and PaaS in your data center. We have about 20 minutes left, so do we have any questions about these so far? No? Went through that data really quickly. So to circle back to your question about SQL Azure Data Sync, this is one of the most common questions I see come up when we go into this type of development. And if you're looking at Azure, there is a section called Databases. And these are all your SQL Azure databases. So when you're syncing up from multiple different premises, you can deploy any database you want out there. And once your database is deployed, you simply go down to Add Sync, and you can add a new sync agent. And what that does is put a synchronization tool on your localized SQL server. You then add a sync group, and you can actually have it synchronize the data between SQL Azure and that on-prem solution. So we use this a lot in this type of scenario if we're doing, say, the catalog approach. And we have a big database that's captured locally that has all of our data and usually runs our site. And we want to put that database that powers the catalog out into the PaaS world. Well, we can choose to only synchronize those tables that contain data related to our catalog and get that out there. So that, again, we can get that backplane connectivity right in PaaS. We can scale up, scale down, et cetera, but keep all of our local private data locally and keep it even in the same database names. So the constructs and the architecture and schema are very, very similar between each. And jumping back over here. So just cover a couple of points of related content. There's a few other solutions that dig deeper into this particular subject area. WADB 338 is talking about building real-world modern apps that span multiple premises. So this would be a great session to attend. Then for the infrastructure side, there's another session on securing apps with OAuth 2.0 and AD, which becomes a very valuable perspective to look at when you're deploying apps out to the cloud. That's WADB 307. There's also a couple of hands-on labs, WAD IL 201-R. That's the Azure IaaS Part 1. There's a Part 2 to that hands-on lab as well, where you can walk through setting up VNets beyond just deploying VMs. And then downstairs in the main show floor area, there's an immersion bar in the Microsoft Server Cloud Tools area that's digging a little bit deeper into Azure. And there's also the Modern Business Apps area where you'll see the Azure guys and a couple of Windows Server guys, so that if you have questions about some of these individual topics, we can get really specific on the area of your app that you're concerned with and walk through it in Azure so you can see it firsthand rather than just having to use this demo as a reference point. There currently is one certificate that's associated with Azure, and that's certificate for 70-583, Designing and Developing Azure Applications. That's going to change very soon. It's a very simplistic certificate that either a developer or an infrastructure guy can pass. But coming soon, it's going to get a lot harder and a little more complex. And after the session's over, if you want to go into deeper detail on any of these subjects, you can find me down at the Server Cloud Tools demo area. I'll be doing a number of demos later on today and tomorrow. So feel free to stop by there. And I also have my contact info on the screen as well. So you can find me at Twitter, on the web, or on my blog site and reach out to me through any one of those three channels. And I believe this deck as well will be posted on Channel 9 with the video. So a few last-minute things to cover for resources and call to actions. So if you're interested in doing the development or testing in VMs, you want to get familiar with it, you can go to windowsazure.com, get involved in a free 90-day trial, and actually start spinning the tires and see if this is something you're interested in. Also, if you've got a MSDN subscription, you can activate a whole plethora of different advantages through that. And if you do so, you can enter the aka.ms Azure contest for a chance to win an Aston Martin V8 Vantage. So a couple of cool things out there. A few other resources included with the slide. There's the Windows Enterprise, the Windows Springboard, the optimization package, virtualization, and Windows to Go. Each one of these are different areas where you can get some more information on Azure and the hybrid scenario and dig just a little bit deeper into the topics we covered today. And of course, you'll see this session and sessions on demand at Channel 9. You can also get some more information at TechEd, at Microsoft Learning, and of course, MSDN. So a couple of different resources for you. And with that, we'll open you up for any questions or comments you guys might have. Yes, sir. Yes, absolutely. So there is some load balancing. When we stand up a cloud service, that does a lot of the work for us. Are you wanting to see more of the VIPs on the application or the VM workloads? Okay. So if we go into the virtual machines here, which is our third tab inside of Azure, and we select any of the virtual machines, there's some parts of it that come to us automatically. So for instance, with our VIPs, we have a DNS that's set when we set the cloud service up or when we deploy the first VM. That's our public-facing URL that we would use to get to this cloud service and all of the contents within it. Now, inside of there, we have a public virtual IP address. This one's blanked out because it's the on-prem one. Let me switch over here. So here's the IaaS PaaS one. It actually has a public virtual IP address. That is assigned to it and is only managed by, or only used in that particular cloud service. The internal IP address as well is automatically set. So those things we can't control. They're just hard-coded into the VIP. Access to those in the load balancer, though, we control in the endpoints. By default, when we stand up any cloud service, all we have is the remote desktop endpoint opened up, and anything else we have to add from there. So if we want to add an endpoint to that, we have two options here. We can either add an endpoint direct to this server, or if we had multiple servers inside of that cloud service that we wanted to load balance, we could choose the load balance option. Unfortunately, I can't choose that from here because I don't have another virtual machine stood up. But if I did, I would choose it, and then I would select the actual endpoint that I want to set up, and it'll look the same as this from here. So basically, I say that I want these 3 servers. Now, the next step is to go in, give it a name, and we'll call this test. Choose whether it's TCP or UDP for a connection or protocol. Specify our public port, so let's do 443 and 443, and we can do port forwarding there as well to make it something different. And we just go ahead and spin that up. Once we add that endpoint, if we've done the load balancing at that point, it will load balance between the two over the public IP to the private servers. Does that answer the question you had?
Yeah, it does. And I'm more of an infrastructure person, so I'm thinking like net scalers. I can choose different affinity levels and different kind of load balancing protocols. I want to see.
Okay.
It looks kind of basic.
It is pretty basic from that regard. You can still choose an affinity group. You can't go as deep as choosing an affinity level. And you choose your affinity group when you actually stand up the VM itself. So we can just walk through that really quick. I'm not going to wait for a full VM to stand up, but if we go to Compute, choose a virtual machine, and do a creation from the gallery, I'm just going to choose a Windows Server 2012. I can choose the version release date and plug in the name here. I'm just going to call it VM Test. And leave it as small. Give it a username of TechEd Demo. Pop in my password. Yep. And then here we're going to say I want to connect this to an existing virtual machine. This is the first part of associating it with another VM that's in place. So that one we were just looking at was the IaaS PaaS. I'll join that one. And it already has a cloud service in place, so public URL is there already. I can choose a storage account. That's more for my actual storage of my VM's database structure, or data structure. And then it automatically chose this affinity group of East US because inside of that IaaS PaaS server that was already in existence, I chose an affinity group either explicitly or implicitly. And anytime we add a new server into the cloud service of that virtual machine, it automatically inherits that affinity group. Conversely, if I was standing up the first server inside of this cloud service, I'd choose standalone virtual machine, give it a public DNS name, so TechEd Demo. Man, I can't type. Okay, I'm not going to spin it up anyway. And from here, I can choose my individual affinity groups, either based on virtual network or the affinity group tied to the virtual network. Difference is this one's going to automatically join the virtual network. This one's only going to use the affinity group to keep it close to the things in that VNet. Or it can choose based on region. So West Europe, West US, Southeast Asia, et cetera. Number of different options there. But these are pretty high-level affinity groups. This isn't a detailed, defined affinity level at the server-by-server level. Does that answer the question? Okay. Any other questions? Yes, sir. Mm-hmm. Yeah, I haven't heard that answer come forward yet as to whether or not they're going to automate that script or not. There's a couple of guys down at the demo bar, in particular a gentleman named Ganesh, who is the project manager over the VNet project. He might be able to give you some insight as to whether or not that's coming and releasable information. Any other questions? Well, thanks a lot, everybody, for joining us for today. I hope you found the information valuable, and please take the time to fill out an evaluation, and we'll see you guys down on the floor.